This was the problem set for period 5. Looking at this one, this looked very much like the one like a couple that we did just before the quiz. We've got two triangles being created by vertical angles over here with lines over here. This time around, we have a bunch of numbers, and we know that these lines are parallel. Well, first of all, let's just write down, let's do it two different ways. This way, we can do the angle, which is what we had done before. We know that angle, first of all, what do we know as our given? We know that xz is parallel to VW because that's given. Okay. And we know that this angle, the vertical angle here, is equal to its vertical angle over here. So we know angle XYZ is congruent to angle VYW because vertical angles are always congruent. And in this case, we know that this angle and this angle, or this angle and this angle, are alternate interior angles. And these lines are parallel. So we can say with certainty that angle XZY is congruent to angle YVW because alternate interior angles are congruent if the lines are parallel. Okay. You can't just say alternate interior angles are congruent because I'm going to ask you, are they always congruent? You're going to have to say no, only sometimes. So now all we have to do is write up the similarity statement, which here would be YXZ is similar to triangle YWV. And that's by angle similarity. But just for fun, let's take a look here and see if we didn't want to play with the parallel lines. We're given a whole bunch of numbers here. We're given that xy is equal to 6, and we're given that yv is equal to 18. We're given that zy is equal to 8, and yw is equal to 24. Now you may wonder, why did I do it that way? You know, why 6 first and 18 here and 8 and then 24? I did smallest first and then the largest, or smaller and then the larger, and then smaller and larger. If there's going to be any proportion that works here, it's going to have to work that way. If I put these two together and these two together, it turns out, first of all, let's just say this is given. And let's say xy over yv is equal to 6 over 18, which is equal to 1 over 3. And zy over yw is equal to 8 over 24, which is equal to 1 over 3. That, of course, means that xy over yv is equal to zy over yw. All of that is just about proportions. And we know that again, looking up here, we know that this angle and this angle are congruent, and we can write that down. Right? Angle angle XYZ is congruent to angle VYW, and that's because they are both vertical angles. And the thing is that we got 18 is proportional to 6 the way 24 is proportional to 8, right? And so these two have the same proportions and the same ratio, and this angle is congruent to this angle. We have side angle side here, side angle side. So we can actually finish this up by saying triangle XYZ is similar to XYZ is similar to triangle WYV because of side angle side similarity. So that helps a little bit too. That's another way to do it. Okay. Looking at this one, but here's what we would need. We don't have all 6 sides. First of all, the 2 triangles are this one and this one. Okay. Both of them share this angle, so we're going to use the reflexive property. I'm sorry. If the ratio of 14 to 16 is congruent to the ratio of 21 to 24, well, let's just see if it is. 14 is to 16. And then the question is that the same as 21 to 24? Well, we can reduce this to 7 over 8. Divide top and bottom by 2. And we can divide top and bottom of this by 3. Yeah, 7 over 8. I think I'm running out of ink. Switch pens here. Go from red to black. Let's say statement, reason. Okay. What do I know? I know AB is equal to 2. BC is equal to 14. DC is equal to 21. And DE is equal to 3. And the thing is, I don't really need the 8.5 part, so I'm not even going to write it down. I know that AC is equal to 16 and CE is equal to 24 because of the addition. Right? All I did was add some segments. So I'm going to just say segment addition. Now I'm going to set up the ratios. AC is to BC as CE is to CD. Okay. And that we know is going to, well, this time I put this number on top, didn't I? So it's going to be 8 over 7. Doesn't matter which one goes on top. Okay. As long as you're consistent. All right. Now, that's just proportions. And finally, we're just going to say angle C is congruent to itself because of the reflexive property. And that's enough to tell us that triangle BCD is similar to triangle ACE because of side angle side similarity. Okay. Now you notice it's important here making the similarity statements match up, because when you look at them, you want to know right away that AB corresponds to KG, that BC corresponds to GH, that CD corresponds to HJ, and that AD corresponds to KJ. Right? All because of the way they are in this statement. And if the pieces are similar, if the two polygons are similar, which it says it is, these ratios have to all be equal to each other. So let's take a quick look and see which numbers we have. We have BC, which is 5. We have BA, which is 19. We have AD, which is 3. And then we have CD, which is Y. Over here, they don't even give us JK, but JH is 13. This is G in here. So GH is X. And KG is 9. So the ratio here, the only one of these where I have a number on the top and the bottom is this one. The ratio for these two figures is 19 over 9. Okay. And that's going to be equal to 5 over x. If I want to solve this, the easiest way to do it is to just, first of all, take the reciprocal of both sides. And then multiply both sides by 5. And we're done. If you try to turn that into a decimal, you're just going to mess yourself up, and then it's not the right answer anymore. This is the right answer, right here. Okay, you can turn it into a mixed number if you want. Turn it into a decimal if you want, if you're willing to go all the way out to figure out how far you have to go to see a repeating decimal. Okay, let's do this one. 19 over 9 is equal to y over 13. Okay, I'm not going to try this in my head. We're going to do 19 times 13. 3 times 9 is 27. 3 times 1 is 3, plus 2 is 5. 1 times 9, 1 times 1, 247. Okay. So the answer here is y equals 247 over 9. Okay. And I know that this is not divisible by 9 or by 3. Because if I add the digits up, 2 plus 4 plus 7, I get 13. That's not divisible by anything. So a couple of sort of odd-looking fractions turn out to be the right answers.